Okay, I've got a table here. Unemployment rate is X and the consumer price index is Y. It summarizes quite nicely. Calculate the product moment correlation coefficient R for the data, and it says it's going to be between minus 0.6 and minus 0.5. Okay, for this I need to go and get the formula sheet, have a look at that, and just substitute some numbers in. So here we have it, and product moment correlation coefficient is given here, and SXY is actually the same as this top bit here, so it actually repeats the formula. I always like using this one. The formula is not given in this way, so I'm going to get rid of that, and I don't like that way, doing it all at once. I prefer doing it separately. So I work out SXY, which is this bottom one, and I don't want to use the middle one, because the middle one there, that's not how the data is given to me. It's given as sum of xy. Sum of xy is 2119. So that equals 211.9. I've got to take away sum of x, which is 70.3, times by sum of y, which is 30.8, and then divide that by n, which is 10, and that equals minus 4.624. And I can work out the other two. Again, I don't want the middle ones. I'm just going to want the other n ones. So SXX is 503.45 minus 70.3 squared over 10, and that equals 9.241. And SYY is 103.94 minus 30.8 squared all over that 10, and that is 9.076. And now I can substitute it into here to work out what R is. R is SXY, that is the minus 4.624 over square root of the other two things thrown together. So 9.241. Let me get rid of that. 9.241 timesing it by 9.076, and that equals minus 0.504906, which equals minus 0.50523 significant figures. So that's the first part done. What's Karen say? She says that it's the negative value of R shows that when the unemployment rate increases, it causes the consumer price index to decrease. It doesn't necessarily cause it. It might, but R shows correlation and not causation. Just because something's correlated, it doesn't mean it actually causes it. That's that bit. Part 3, A, I'll do up here. I've got to calculate the regression line of x on y. Okay, that's a tougher one because that's not what's given down here. It's given out y on x. So knowing x on y, I have to replace every x with y. So that'll be x on y is, instead of having y equals a, is going to be x equals a plus b, and that become y. I suppose very often you put a dash in there, so it's a different a and b, and where a dash now equals x bar minus b y bar, and b, the regression coefficient b, so b now, my new b, is going to be sxy is going to be syx, but that's actually the same thing, over sxx. I have to replace the x's with y's, so syy. And so it goes, that's everything we've got. I'm trying to get x equals this bit. In order to work out what that is, I need to know what a is. But in order to work out what a is, I need to know what b is. So the first thing I've got to do is work out what b is. I'm doing it up here. So b dash equals sxy over syy, which is minus 4.624 over 9.076, and that equals minus 0.509. So let's work out what B is, and now I need to find out what A dash is. And A dash is X bar, which is 70.3 over 10, minus B dash, which is that number there, negative 0.509475, times by Y bar, and Y bar is 30.8 over 10, and that equals 8.599184. And so now we get X equals 8.60 to three significant figures minus 0.509Y to three significant figures, because that's the formula I'm trying to get. X equals A dash plus B dash times Y. And now part B, we got to work out when X is 4, so when Y is 4%, so I'm going to get X equals 8.60 minus 0.509 times by 4, which equals 6.56212. So X equals 6.6 to two significant figures. And I put two significant figures here. It's because these numbers here are all given to two significant figures, so I'll keep the same sort of accuracy. And that's question 5 done.